Hello, everyone. Looks like we have a bunch of attendees walking through the front doors of our virtual conference hall. So we'll give folks a few seconds to get seated, and we'll begin. Once we hit the magic number, just about there. There we go. We just hit the magic number. Wow, lots of people. Thanks everybody for joining. I hope you're joining us safe and healthy and happy from the comfort and security of your own home. Since so many of us are working from our homes, go ahead and tweet a picture of your work from home setup and include hashtag VDI Summit so we can see how creative you've gotten. If you have any questions, please use the Q&A button at the bottom of your video conferencing of the Zoom bar down there and ask your questions. If we can't get to them during this session, we'll make sure they'll answer them for you at the Tintri booth, or we can always make sure Rob gets with you afterwards. Stick around for a raffle after the event. Thanks to Tintri for being a sponsor, and thanks to our other sponsors. So today I'd like to introduce our speaker, who I've had the pleasure of working with for many years. If you've been to VMworld, you've seen him walking around with a pretty cool mohawk. And when it comes to storage, VDI, and databases, this guy has optimized it. So joining us from his home in San Jose, I'd like to introduce Mr. Rob Girard. Take it away, Rob.
Thanks, Blair. Great to be here, and thank you everybody for tuning in. I've got 15 minutes, so I want to pack this really full. So I was on last year, and so this is going to be a continuation of that. So I don't want to rehash that. So let me just stop my video here, and let's continue on. Okay, so recap from last year. I had the a view presentation. I'd like you to view this presentation. It's on YouTube. Also, if you come by our booth, you'll see it. So if you haven't seen the links in the booth, you can see there's a videos right there. And then down below, there's view. And this will pop that link out. I also have a second link in there that I'd encourage you to watch. So this was 15 minutes jam-packed full of Tintri goodness. And so I'm just going to continue on where that left off from that bottleneck virtualization session. Now, intelligent infrastructure, specifically the Tintri VM store, this is storage that's purpose-built to make your life easier. And at the core of it is a file system that has been built to support virtualization. So this is a custom-written file system. Lots, like hundreds of person years have gone into the creation of this, starting back when we were founded in 2008, and then we GA'd in 2011. So I don't want to, what I want to do is get straight to a demo to try and demonstrate the nuances of this file system, because this is really the set it and forget it. So as much as in the past, I've always shown our graphs, and I'm going to continue to show our graphs and all the granularity of all the data we have because of this file system we have. What I really want to demonstrate to you, though, is how it will protect other systems from other systems and dynamically change who's more important than others through our auto QoS. So for a full, an excellent walkthrough of intelligent infrastructure, if you've got 9 minutes, that link at the bottom there, which is also linked from our booth, was from my colleague Erwin Daria, and he did a fantastic job on that. So. And I'll just get this chat going down below. Okay, pasted in by someone. Thank you very much. Okay, so I want to jump into a demo. So this session is really a favorite topic of mine. It's the you know, I like to play Sherlock Holmes, and I think that we have so many common infrastructure problems that you shouldn't need to be in a Sherlock Holmes to be able to solve them. So I would always say that trouble avoidance beats troubleshooting any day. So just not having the problem is better than having all the right tools to solve it if you do. Now, if you do have an issue and you've already gone through all the avoidance steps, having that rich troubleshooting is incredibly powerful and important. And so what I want to do is try and demonstrate for you QoS in action. So this auto QoS of ours, and so just to demonstrate this, I'm going live here. This is, you know, maybe a little risky, but you know, no more risky than anybody working from home doing their mission critical stuff, or working in an office or a doctor's environment where they need their sessions to be dependable and reliable. Now, so this desktop that I'm sharing out, that's where I'm running a PowerPoint from. Let's just jump on here, and host name is RGadmin. So this is the machine that I'm on, and I'm going to go over to the Tintri UI, and I'm going to click in just to see the total IO that's going through right now, and I'm going to do a stack graph with latency at the bottom. Now, I'm going to talk through this fairly quick because I know this is being recorded, and after the fact, you can rewatch it if I went over something too fast. But so down at the bottom here with latency, we've got an end-to-end latency that we can see. And if I click here, I can see top contributors. So even though on average on this box, for the 600, 700, 800, however many systems I had at this time yesterday, it looks like 60 milliseconds, and most of that's coming from host latency. But we can see there's some really rough outliers, and I'll cover them shortly. But what I want to show you is that just because this average on the box shows that does not mean that everybody's impacted the same. Now on our top graph here showing IOPS, IOPS are my least favorite value because they don't mean too much if you don't know what the block size is. So just like RPMs in the car, if I'm driving 5,000 RPMs, am I breaking the speed limit, or am I have people honking at me because I'm not going fast enough? If I check this box, this is QoS, what this will show me is normalized IOPS. So if each IO was an 8K IO, then this would be that sort of relative value. So I like to think of it as my apples to apples meter, so I'm not hitting any blind spots. So right now, live on the box, I have, let's just confirm on this. So about 3 hours ago, or 2.5, I started off a LoginVSI load with 800, and 798 of them went live, and I tried to time that so it would peak out right about now. So it is in the peak, and now these are going to run for the next 3 hours. So we've got 800 desktops running on this single 2U all-flash VM store, an EC6090. My jump box is on there, and I've got a whole list of other systems on there as well. So let me just go to the list of VMs, and I'm going to get a few tabs going here because I want to demonstrate how every experience is not the same. So just because something says it got latency, others may not have gotten that latency. And so specifically, I want to pull up RGadmin, which is the desktop that I'm broadcasting from right now. And if it goes choppy, you know we're going to blame the internet connection. It's got nothing to do with the desktop session. All right, so let's just take a look at the individual latency for RGadmin. So this is IO, and this is underneath it, that latency. And this is a stacked graph showing host network storage. So this will correlate directly to latencies observed by the applications within your desktops, within your database servers, all your other VMs. So I'm going to take another VM here, and I'm going to use this as my canary in the coal mine, I guess you could say. So in this case, I want the vSA. So this is the vCenter, or one of the vCenters. I've got several in this environment. This vCenter in particular always has a slow trickle of writes to it. And what I want to show you is that the latency on it, and we can see little spikes in the environment around there on the hosts, but nothing really to do with storage. Storage is all way sub-millisecond, 0.2 milliseconds. And now in the real time, as it comes out from the right, these are 10-second averages, and it's 10-minute averages on the left. And one more thing I want to grab is one of those desktops that was running the LoginVSI workload, which is a knowledge worker to vCPU workload. And so this is going to be a VDI-Summit. And I can look at high to low all of those desktops. Some of them have some host latency in them. Some have a little more, may have some storage latency. So I'm just going to pick on this guy. He's not the worst defender, but you can see that he's bad as it goes. This one has it the worst with some network latency coming in there. So I'll just get this one going to see some real-time stats for it at 10-second averages. And we'll get latency going down here as well. Okay. And when I check this little box here for QoS, that's going to break down my storage into some subcomponents. And as we see those, I'll explain what those are. So now we can see this pattern here. These are 10-minute averages, and this is the real time on the right. So this is what normal looks like for this vCenter. This is what it looks like me running all through last night, right up to this demo with my vCenter and all the stuff running on this desktop. Oh, sorry, the vCenter is not running here, but my clients are running here. And then the array itself. And again, this is a little blinding here because here's a straight flat line. And if we were to look at what throughput would look like, we can see that even though the IOPS looks flat, our block size has been growing and it's actually been changing a bit. As we went from 0 workers to 800 workers over the course of the past few hours. Now on my system, I am going to grab some data and I'm going to highlight these, which is 7 gigs of data. And I'm just going to take this and I'm going to copy it into my local drive right on the same box and paste. And I'm doing this so that you can see that I'm not kidding around when I say like, hey, look, my VM is in here with the others. Now, I didn't have to set up any LUNs, any volumes. All I need to do is just present this data store and tell the VM store what my hypervisor managers are. So register all my vCenters, Hyper-V hosts, Zen servers, Red Hat Enterprise Virtualization, and we support a few more as well. Now here we can see I've got some IOPS going, my least favorite value because these are those RPMs in a car. And what I can see here is I got some storage latency. I got a total of, looks like 7.9 milliseconds of storage latency. Now 6.7 of that was contention. What is contention? That means that my norm for what I normally do did not allow me to have priority over other things when I ramped up and I took 1800 IOPS. Now this 1800 IOPS, just to put in perspective, because I just did copy 7 gigs, if it were normalized IOPS, this is equivalent to somewhere close to 60,000 IOPS. So this is very large block size. This is 256K block size, so it's 32 times bigger than any of the 8K stuff that we would show. And I'm very conscious of time here. We've got 3 minutes. All right, so what happened to the others? You'll notice that vCenter just kept on going. We had some load. If I didn't have any load, I wouldn't have anything to measure latency with. So just the normal load of the vCenter, and you can see that storage latency never went higher than 0.2 milliseconds. Now the network latency increased a little, but you can see that I was not impacted whatsoever. Now let's take a look at that desktop we were running. This is the LoginVSI workload on it. If I check this QoS box, we can see, okay, it's not all as it seems, right? Some spots are hotter than others when it's larger block size operations. And down below here, again, not impacted at all. So this is the invisible magic under the covers. I don't have time to do it right now, but what I was going to do and love doing is take all 800 of those and reboot them all in one shot right now, because what happens is my desktop will not be impacted by that. And that is the difference between intelligent infrastructure and standard infrastructure. Now, really quickly, I've got one more thing I wanted to cover here. And I know I only have 1 minute, so I'll do it that quick because I'm that confident and because I set it up ahead of time. So here's the whodunit that I promised. Is anybody feeling pain? And let me just go right back over and let's take a look in this environment. Now, when I click here and I get these top 10 contributors, I can see that I've got VDI Summit 420 at 36,000 IOPS. I've got COVID Cure at 1,200 IOPS, and then everybody else is smaller, and I can see the latencies for those. So now I found out the hotspots. The COVID Cure is running a folding at home. to try and help break down proteins and fold them and find some cure for coronavirus, doing my part with my lab infrastructure. And let me just jump over to, and I see that time is up, but this part's really important for those who tuned in. I've got a system here that I want to open and look inside to see what it's doing and why it's driving those 36,000 IOPS. And, oh, prize alert. What do we got inside here? Now, the first 2 attendees that go to the Tintri booth right now and in the chat, type in Tintri Whodunnit in the main chat. So I know you're paying attention. We will send you VivoFits. So we've got 2 of them to give away. The first 2 people in there, I've got booth reps in there to qualify it and judge it. These will be yours. Thank you very much for tuning in and attending. I would love to stay on longer, but I've got to be respectful of my time and those of yourselves and other presenters. So thank you so much for having me again this year. Hopefully this was helpful, and I'd love to answer questions in the booth.
Well, thanks, Rob. Always an exciting demo that you give us, and great to have you. Check out the next session. You have about 4 minutes to get there. It's by our friend Lee Jeffries, who's going to tell you how to get 1,000 users to run at the speed of light. Very appropriate for these times. So have a good one. Thanks for joining, and we'll see you in the next session.